Welcome back to my YouTube channel. We're still on Surd part 6. So in this part of Surd, we'll be looking at rationalization of Surd. In our previous video, we looked at division of Surd, so you can still check the video out later. Basic rules that, or should I say, the basic step that has to do with rationalization. The first one is we should identify the surd in the denominator. Now the second one is we have to multiply the numerator and the denominator by the surd. So to rationalize the surd, you should recall that the basic step is one, we should identify the surd in the denominator and then multiply the numerator and the denominator by the surd. So the surd we have here is root 2. So I'm going to multiply the numerator and the denominator by root 2. So I'll have times root 2 over times root 2. So 1 times root 2 would be root 2. Root 2 times root 2 would be root 4. So if we are to simplify further, we'll have root 2 and then the square root of 4 is 2. That will leave our answer to be root 2 over 2. In this question, we are asked to rationalize 1 over root 19. Therefore, we are going to multiply the numerator by root 19 and then the denominator by root 19. So this would be root 19 all over root 361. So therefore, simplifying further, I'll have root 19 over 19. Just to simplify root 6 over root 48. The first thing I'm going to do is I'm going to break down root 48 to its simplest form. That will be root 6 all over 4 root 3. So therefore, to multiply the numerator by the denominator to rationalize and also multiply by the denominator. So therefore, this would be equal to 4 root 18 all over 16 root 9. So I'll be having 4 root 18 all over 16 and root 9 is 3. So this will be 4 root 18 over 48. Now looking at what we have up there, 18 is not in its simplest form as a surd. So reducing this to 18 to its simplest form with 18 would be 3 root 2. So multiplying that with 4, that will be equal to 12 root 2 over 48. So I'm going to do my division. 12 will divide here 1 and 12 will divide 4. This will leave our final answer to be root 2 over 4. Let's try this next question. We have root 12 over root 156. You can pause the video, give it a try, then come back to know if you actually got the answer. The first thing I'm going to do is reduce this surd to its simplest form. I'm going to reduce root 12 to be 2 root 3 and then root 156 to be 2 root 39. I have a video already uploaded on how to reduce surd to its simplest form or how to completely simplify surd. You can actually check that out. Now I have this, the next thing I have to do is to rationalize. I'm going to multiply the numerator with 2 root 39 and the same with the denominator. 4 root 117 all over 4 root. Bottom of this point, so 4 would cancel 4 and we are left with root 117 over root 1521. Then I'm going to reduce this surd to its simplest form. Therefore, root 117 is 3 root 13 and then root 1521 is 39. And 3 will divide 13. And that will leave our final answer to be root 13 over 13. Now, we are the numerator and the denominator by the number at the denominator, but actually changing the sign. For example, the conjugate, that is what we call the conjugate. The conjugate of this denominator is 3 minus root 5. That is changing the sign. Therefore, for me to rationalize this surd, I'm going to multiply the numerator by 3 minus root 5, and then do the same with the denominator, which is 3 minus root 5. So I'm going to quickly have my multiplication. Here will be equal to 12 minus 4 root 5. And here I will have 9 minus 3 root 5 plus 3 root 5 minus root 25. Or you can simply remember one of the classes we had when I told you that if two surd multiply, or if two irrational numbers multiply, like rational numbers multiply, it will give us this number, but in the rational form. That means that root 5 times root 5 will give us 5. Root 2 times root 2 would give us 2. Root 3 times root 3 would give us 3. Okay. You can either apply that, or root 5 times root 5 will give us root 25. So I'm going to keep solving. I'll have 12 minus 4 root 5 all over 9. Negative 3 root 5 and positive 3 root 5 would give us 0. So I cancelled that out. Then this will be minus. What would be root 25 would be 5. Then I'll have 12 minus 4 root 5 all over 9 minus 5 would give me 4. Solve further by factorizing the numerator. So what we have common here is 4. 4 in bracket would be 3 minus root 5 over 4. So dividing this out, we're left that our final answer is root 5. We're going to multiply the numerator and the denominator by the conjugate of the denominator. So what we have here is negative sign. So that simply means I should change the sign to positive and multiply it with the denominator and also with the numerator. I'm going to multiply this by root 8 plus root 7. And then I'm going to multiply this one again with root 8 plus root 7. Multiplying this, I will have 6 root 24 plus 6 root 21. Then all over, this will give me root 8 will give me 8, or you can still do root 8 root 64, whichever one that works for you. So root 8 would be root 64. I'm going to break it down. Now this will be plus root 56, and this will be minus root 56, and the last one would be minus root 49. So solving this, I will have 6 root 24 plus 6 root 21 all over. This will definitely give me 0. So I'm left with root 64 minus root 49. So now it's time to solve completely. First of all, I'm going to break down root 24, and that will be 2 root 6. So multiplying with 6, that would be 12 root 6 plus 6 root 21. And then down here, I'll have root 64 to be 8 minus root 49 would be 7. Therefore, this will leave me with 12 root 6 plus 6 root 21 all over 8 minus 7 would be 1. So this would be the answer, because anything divided by 1 is still that number. So I can still decide to factorize. I have 12 and 6 common here. So they have a common factor. So I have 12 and 6, which have a common factor of 6. So I'll have 6 in bracket 2 root 6 plus root 21. So this would be my final answer.